Okay, so we're back again to the use of the formulae that we derived in the previous presentation. We had this, we have this, and we also had this. Now, supposing we have here the transformation of the metric tensor represented by this. This is a normal tensor transformation. You have this to be written as that. The x rho, the s prime mu, the x sigma, the s prime mu. Essentially, what we intend to do is to find a relationship between the affine connector, or you can say the Christopher symbol and the metric tensors here. Now, one of the things that we intend to do in this process is to derive a result such as this, this, and this, and combine them in that form in the last year, written in this last expression, and see what it gives us. Now, for instance, here, if we were to differentiate this entire expression, that is the g mu prime, the x prime k, what is that going to give us? So we go through by the usual Leibniz method or Leibniz rule. This is going to be the g rho sigma, the x prime k, and then we're going to have this rho, the x prime mu, the x sigma, the s prime mu, plus the next thing we do, we have this to be written as g rho sigma, the 2x rho. I'm going to go straight ahead to do that because, like I've said before in the previous presentation, these are just differentials. And we have no prime on top, so the primes are just restricted to down. I can just do that to make things simple, easier for me. Next, I have this, and this is going to be the s rho, the x prime mu. Then here, over here, the x squared, okay. So that is the 2x sigma, the x prime k, the x here prime mu. Okay, this is what we get. Now in the next step, what we intend to do is, remember we're trying to find a transformation. So actually here it will look like we're trying to find a tensor equation for this object here on the left hand side. So I may want to do something like this, the g rho sigma, the x. Now I'm just looking for something completely out, say delta. Now the x here, I can say delta. Here, I'm left then with the x prime k. Yeah, I could do that actually, especially if I had this right from the beginning. That's if I had this placed here, but it doesn't matter what position it takes. And next I have the x rho, the x prime mu, the x sigma, the x prime mu. Now I have plus the other terms here, g rho sigma, the 2x rho, the x prime k, the s prime mu, the x sigma, the x prime mu, plus g rho sigma, the x rho, the x prime mu, and the 2x sigma, the x prime k, the x prime mu. Okay, now at this point you can see, of course, that were this to be a tensor, really, in a manner of speaking, as we will define a tensor, all we will have is this first term. And this two wouldn't be there, but now this already spoils the tensor character of this partial derivative of the metric tensor. As we can see, the metric tensor itself is indeed a tensor, but its partial derivative is not a tensor. Now at this point, of course, like we said, these are all delta rho sigma on top. Now it's also a manner of just calling this some objects all contravariantly. Now the next thing we can do is to calculate this. So in the same way that we have calculated this, we're going to calculate that. But first of all, we may want to define what, for instance, is g sub k nu prime itself. How are we going to define this? Now we are going to be, well, it doesn't matter really, because in the end we are still going to have to change every dummy index into what will be most suitable for us. So for instance, in this case, what we can do is to just go ahead and say that this is some g. I already have a delta here, so I don't want to confuse things. Well, it doesn't matter really. So I can say g delta rho, so that this becomes the x delta, but then this becomes the x here prime k, and then here I have the x rho, and then this becomes the s prime nu. It doesn't matter, in the end we'll be able to reshuffle things and make them look just like what we want them to look like. So we can just proceed. So just like we did before, the very first step here, the g here, prime k nu, and we're differentiating that with respect to the x prime nu. Okay, now then this should be mu and not nu. So I wanted to differentiate this. So what I've done before was this, differentiating with s prime k. Now this is the gk prime, the g prime k nu, differentiated with respect to the s prime mu. So the next thing I'm going to do, as usual, again, I could write off right from the beginning, make everything look so simple, since after all that's what it is, so simple. I can just choose here as a dummy index, something here that is, say for instance, the g, what I have over there is delta rho. So I can just choose a dummy index. The x here, of course, I can decide if I like. I have a rho here, but then no sigma, so I can bring in the sigma. This becomes the x sigma, but then here the x prime mu. And over here, sorry, as you can see, it has to be exactly this, because now I'm treating this by Leibniz rule. So the very first thing I've done is to have differentiated this first factor, which is g delta rho. So all I'm going to do is to copy the rest of the factors here joining this. So this is the s delta, and this is going to be the x prime k, and then the following is the x rho, and I have here with me the x prime nu. Plus, I leave the first, I treat it as a constant, and the next I'm going to have the 2, this delta, the x prime mu, and the next is going to be the x prime k. And of course, this remains untouched. We'll leave it alone. And the next will be plus g sub delta rho again. I leave the second factor all alone. The x prime k. Now this is going to be the 2 x rho, and next I'm going to have the x prime mu, the x prime nu. And that gives us the derivative for the second tensor, or metric tensor. Now again, we will of course want to, so just to have them all in the same place, I think it would be nice if everything is right on with. It's fine, we're doing it now. So this is g here, and that is k mu prime. I think that's the next thing we're about to do. We're going to differentiate that with respect to x prime mu. And we can define this again. Well, we're trying so hard not to proliferate the dummy indices so that we can be able to keep track of them. But that doesn't mean we won't be able to, or wouldn't have to make some changes every now and then. Well, let me just, for the sake of argument, use gamma here. And I guess I've not used, well, I might have used alpha somewhere, but I'm sure I've not used beta. So this is going to be here, the x gamma, the x prime k. This is the x beta, the x prime mu. And that is how you get that. Now what do we need to do, or what do we want to do next? We want to differentiate the g prime k mu with respect to x prime nu. So the usual thing, the very first term that we have here, in this case is that. And remembering what we did always from the first to the second expression we obtained was to make sure we keep the primes away from this metric tensor. So what do we do in the first place here? We are going to do something like this. The g gamma beta, for instance. Let me say this is the, I haven't used a tau here, have I? I think I used a delta here for the first time. And then I used a sigma. I don't know why I'm avoiding tau anyway, but fine, let's just go ahead. The tau, it wouldn't change a thing. If we have need to change it, we will. It's a dummy index. So the next thing is going to be the x tau. And now, of course, this was the s prime nu. And this was our intention. And it means we have differentiated this first factor. Now, all we have to do is simply to write these two differentials. The x gamma, the x prime k, the x beta, the x prime mu. Now the next thing I'm going to do is the usual thing plus. We just treat this as a constant. The 2x here, gamma, the x prime mu, and I have here the x prime k, and the next thing is the x beta, the x prime mu. Okay, plus, I'm supposed to, let me put that here, plus g here, gamma beta, and the x gamma, the x prime k. Okay, sorry, these things. Usually when you're dealing with tensor analysis and so many Greek indices, you be careful what you write. S and a beta could be misconstrued for a gamma. So this is the s prime k, and now this is going to be the 2x beta, the x prime mu, the x prime mu. And that's it. So we have three expressions. If you like, you can call this 3. You can call this 2. And this was our first one. So exactly. So we had this, the g mu nu, the x prime k, and that's it. Okay, so what do we intend to do? What we intend to do next is to find an expression like this. So for instance, out of all these expressions, I'm guessing what we had the first time was this. We differentiate, oh no, this was our third equation. This was, okay, our second equation, that was equation 2, I'll say. And our first equation, or the third equation, is that with respect to mu plus 3. And then the very first equation was with respect to k, so minus 1. In other words, what I intend to do right now is to find the g prime k mu, the x prime mu, plus the g k mu prime, the x prime mu, minus the g prime mu nu, the x prime k. This is what I intend to find. Okay, so let me just put this as equal to this. I guess it will be far more helpful. Yeah, so this is what I intend to find. But however, I think maybe I should deal with some of these inhomogeneous terms first. Inhomogeneous terms such as this, before I attend to these very first factors. Now, in the very first term or second term, yeah, the second equation, which is this, I am supposed to add it to this. However, take note of the fact that I'm going to be minusing the terms here. Okay, now I think what I will do, yeah, so I think it will work perfectly well. So this is what we are going to do. We are supposed to add equation 2 and equation 3. Now, the homogeneous terms I'm referred to as this and this, excluding the first one, this excluding the first one, again this and this excluding this one. So I'm supposed to say this plus this minus that. So first of all, let's look. Is there any of the terms here that looks similar to any one of these? We have made a point before. Rho and rho, sigma and sigma on this term, for instance, are all dummy indices. Now looking at this term, is there any one that could be the same with this? Because the important point here we are looking at is for the homogeneous term, this order has to be maintained. Now I can already see one, like this one for instance. Let me give it a similar label. Let me give it say 1, and this say 1. These two terms look exactly the same because you can see this rho, rho, sigma, sigma. I have delta, delta, rho, rho. These are all dummy indices. So this is the same. And also the partial differential here associated with this first one, the inhomogeneous term that we always call it. You can see I have prime k, prime mu. Prime mu, prime k is all the same. This is commutative for this particular factor. And then prime nu under this one. So this term and this term are the same. But given the fact that this is part of equation 1 that is being subtracted from the sum of 2 and 3, you can see that this term cancels that. So just trying to avoid redundancy, so please, you can just follow this as easy as you can if you're seeing this for the first time. Now again, looking at this, what other term does this look like? Now you can see again we have two dummy indices here. Now this one and this one are not the same because this homogeneous term has prime k, prime nu. But I have here prime mu, prime nu, so these two are not the same. I will have to leave this alone. Again, but which of these terms here does this look like? I have prime nu, prime k. We're in log. I think here this is what we have. So we have here prime k, prime nu, prime k. So this, in a manner of speaking, is the same with this, because if you look here, this is gamma, gamma, beta, beta. So in essence, it's the same with this, which has sigma, sigma, rho, rho. So again, this term here cancels this one. That's in our business of saying 2 plus 3 minus 1. So in terms of the homogeneous terms, every such inhomogeneous terms, every such inhomogeneous term have been cancelled. They are gone out of the expression. So let me write them first. In other words, I'm left here with simply G delta rho, the X delta, the X here prime K, and the X, the 2X, that, the X prime mu, the X prime nu. And I'm left that also plus here, G gamma beta, the X gamma, the X prime K, the 2X beta, the X prime nu, the X prime mu. Okay, so that's it for the inhomogeneous terms. Now for the very first terms of each or all the expressions. Now remember what I was supposed to do. What I was supposed to do again was to add this term, this one, plus this one, but minus this one. Minus of that one. I'm supposed to subtract this. It's just exact or whatever. Okay, I think this was our final expression. Minus this one. So this was what we were dealing with all along. So how do we do this? Now we can see we have dummy indices all along across these terms. For instance, here I have tau, tau. I have gamma, gamma, I believe. I have beta, beta. Of course, the only things that are not repeated here are the ones under here. Now, if you look at this one too, you can see these are just the ones here that are not repeated. Delta, delta, rho, rho, sigma, sigma. The same, of course, is here. Delta, delta, sigma, sigma, rho, rho, except the ones down. Now, I want to rewrite these terms. So I'm going to rewrite these terms in a manner of speaking, of course, with the appropriate signs. But with the idea of making sure that each of these differentials here look the same. Why am I doing that? Because I know where I'm going. I know what I want to do. But I think the best thing here actually is just to look at it that the fact that these are dummy indices, it gives us some freedom into how we can manipulate these tensors. Now, for instance, the very first, second and first one, let me just look at it this way. I can choose anyone to be my reference if I want, and that's not a big deal. So I have the X delta over K prime, the X rho over mu prime, the X sigma over nu prime. So I can take that to be the standard, that every delta should be over this, every this to be over that, and that to be over that. So in other words, let us start by doing this. In this first term, for the second and the third term, so this is how we're going to go about this. So we are going to say, for instance, we've done this, we said this is going to be plus. For the second term here is going to be the G. I have here with me delta rho, and this is supposed to be the X sigma, and I have there also the X sigma, the X prime, I believe that should be mu, and the X here delta, the X prime K, and here the X rho, and this is going to be the X prime nu. Okay, that's it. Again, we are supposed to add it to this third one here, and this is also plus the G gamma beta, the X tau, the X tau, the S prime nu, the S gamma, the S prime K, the X beta, the X, just to avoid any confusion, right? That. And this is supposed to minus the very first one here, the G rho sigma, I guess, the X delta, And what follows next is the x delta, the x prime k, and the next thing is going to be the x here, rho, the x prime mu, the x sigma, the x prime nu. This is what we're supposed to have. Now, how do we deal with this? Okay, now, like we've said before, in this term here, I'm going to use this as my reference. Let me just use that as my reference. But in doing that, I can see that over k here, okay, so this coincides. I have delta over k here, delta over k here. I have rho over nu. So here, I don't know if it is the same. Over k is gamma, but that's not a problem. So let's just deal with this one first because it's easier. You can see I can decide to make a transformation between rho and sigma on this particular term. That is, replace rho everywhere with sigma and sigma everywhere with rho. If I do that, you can see that my rho here, which was over mu prime mu, I will have a rho here also over prime mu. So please, for the sake of argument, this very first term, I'm going to combine and call them all firsts. Sorry, just to make things a little bit elegant, let me not term. So the very first term here, the combination of that, we are going to come back to that later on, plus. Now remember the transformation we said we are making for this particular term. Just interchanging. So this is going to be G here. We are leaving delta where it is, but we are changing rho on that term to sigma, and we are changing sigma on that term to rho. And then this is the x sigma, the x prime mu, the x delta, the x prime k, the x sigma, the x prime nu. So we are good with that term. Now the next term is this. Now the next term looks like everything here is haywire. This, we have beta here. First of all, what is under beta was supposed to be, what is under x prime mu was supposed to be some rho. So on this term, we are going to change our betas to rho, just so that it will coincide with that. We can do that because beta occurred twice, the dummy index. So if we change beta to rho, what about the terms under x prime nu? Is a tau and not a sigma. So again, we can change the tau to a sigma. Again, we can do this because tau occurred twice on this term. And what is the next transformation we will need to complete this? What we had under x prime k here was a delta, but we have a gamma here. So we can change the gamma again to a delta. We can do all this again because, as you can see, we have a gamma here and a gamma here. These are all dummy indices. So in other words, this is going to be plus the g. We have here a delta. Instead of a beta, we have a rho. And then I have here with me the x sigma, and then the x, instead of tau sigma, the x prime nu, and the x here, our gamma becomes the delta, the x